Okay, so this will be our first exposure to triangle congruence proofs. And so we want to keep in mind anytime that we want to prove that triangles are congruent, so far the ways that we have of proving triangles congruent are SSS, SAS, and ASA. So we're going to be looking for one of those three scenarios. So remember that AAA does not guarantee congruent triangles because the triangles could be a different size. And then we found out yesterday also that SSA does not guarantee congruent triangles because there are sometimes two different ways to form the triangle. Okay, so I'm going to do this first proof using a flowchart proof. Now we can do these by the two-column proof or by a flowchart proof. It doesn't matter. I'll let you choose in the assignment which methods you want to use. But I'm going to do this one as a flowchart proof. And typically the strategy is when we're doing a proof, we want to try to think through the whole proof before we write anything down. Okay? And so I'm going to start off by marking the givens on the diagram. So how can I mark the fact that these two segments are parallel? So if we put a line on each one, that shows that those are congruent. So that's not what we're trying to show. We're trying to show that they're parallel. So we have a different marking system for showing that they're parallel. Robin? Did you have your hand up? No? Okay. So we can use what the book uses is these shaded in arrows. So you can do arrows like that to indicate that the lines are parallel. That's what they use in our textbook. Another way that people mark that lines are parallel is like this, by putting arrows like that. So either way is fine as long as you have some system for marking the lines that are parallel. Okay, and then it says that DK bisects segment JE. So is there some way that I can mark that on the diagram? Think about what it means for one segment to bisect another. What can I mark, Grant? That's true. That's what a bisector does. So how can I mark that? It doesn't say perpendicular. It just says that it bisects it. So how can I mark that it bisects it? Robin?
Oh, in between E and G, you can put like one line and then G. You can put a line and then
Good. That's right. So if DK bisects JE, then JE is being cut into two equal parts. So I've marked that on the figure. Okay. And now is there anything else that I can mark on the figure? Is there anything else that I know is congruent? Anjali? That's right. These two angles are congruent. And how do we know that? Those are vertical angles. And we always know that vertical angles, in any figure, vertical angles are going to be congruent. Okay? So what we have marked so far is one pair of matching sides and one pair of matching angles. Now we're going to need more. And so the fact that the lines are parallel, does that give us anything else? Robin? It doesn't say anywhere that DG and DK would be congruent. I know that they look like they might be, like you're saying that segment and that segment are congruent, but they probably are, but we don't have any evidence that they are. It doesn't say that DK is being bisected. It only says that JE is being bisected. Okay? So what do we know, Max? DEG and KJG they have the same angle. How do we know that?
Because the parallels, so that's the same, and the lines is exactly the same too.
So what do we call that when we have parallel lines and we have a line that crosses them, and so you're saying that this angle, which is where angle E is the same as this angle where J is. So there's J and there's E. What do we call that? Alternate interior angles. So you're right that angle E would have to be congruent to angle J because those are alternate interior angles and the lines are parallel. So when lines are parallel, we know that alternate interior angles are congruent. Okay, so E and J are definitely alternate interior angles. So that's good. So now look at the diagram, and what do we have? Do we have congruent triangles yet? We have one pair of matching angles. We have another pair of matching angles. And we have a pair of matching sides. So yes, we do have, in this case, it would be angle, side, angle. For both of those triangles, we have angle, side, angle. And so that's enough to say that these are congruent. Okay, so now we're ready to write our proof. So the first given says DE is parallel to JK, and the reason is that that was given. Okay, and then we had another given which said that DK bisects JE, and that was also given. Okay. Now remember, in a flowchart proof we use arrows to indicate logic. So did the parallel line information lead us to another fact? Yeah, Max told us. It led us to what? It enabled us to say that angle E must be congruent to angle J, and the reason? The alternate interior angles theorem. Now, I don't care if you state the theorem by name like that or if you say what the theorem says. Sometimes you won't remember the name of a theorem, but you know what the theorem says, and so if you want to write it out in your own words, that would be okay. So instead of saying the alternate interior angles theorem, you could simply say, when lines are parallel, the alternate interior angles are congruent. And that would be stating the theorem instead of naming it. Okay, so that would be fine either way. Okay, now this information about DK bisecting JE, that led us to some information. What did that information lead us to? Something that we marked on the diagram. Yusuf?
Line EG and line GJ are congruent.
Okay, good. Segment EG is congruent to GJ. That's what we marked on the diagram. And how do we know that? That's the definition of a bisector. Definition of a segment bisector. Okay, good. So now what we have is a pair of matching angles, so I'm going to label that with an A. We have a pair of matching sides, so I'm going to label that with an S. And then we had something else that we marked on the diagram. What was that? Robin? That's right, and that was the vertical angle. So angle DEG. DEG. DEG or GED, it's the same thing, right?
I thought it was an
It is. Oh, you're right. The vertical angle, it's my mistake. So you're right. It was DGE. Angle DGE is congruent to the angle that's across from it. So that is JGK, angle JGK. And the reason, how do we know that's true? So you could just say vertical angles are congruent, or you could say the vertical angles theorem or the vertical angles postulate. Something to indicate that those angles are congruent because they are vertical angles. And notice that there's nothing pointing to that. There was nothing else that led us to that fact. That's just true of always of vertical angles. Okay, so that gave us another pair of matching angles, and now we have enough to say that the triangles are congruent because we have two A's and an S. So we have angle, side, angle. And so now we can say triangle EGD is congruent to triangle JGK by ASA. And I'm going to move this down a little so I have a little bit more room to draw my arrows. So what led us to that fact? Well, we said ASA, so we should have all three of these pointing because all three of those facts were needed in order to prove that. And so in a flowchart proof for congruent triangles, you usually are going to have three arrows pointing to the end because we have, it's either going to be SSS, which would require three bubbles pointing to it, or SAS, or ASA. So all of those require three parts. So you're going to have three different bubbles pointing to the conclusion when you're trying to prove that triangles are congruent. Okay, any questions on that one? Okay, so the next one we'll do as a two-column proof so you can see what that would look like. So go ahead and copy down this example. Okay, so this proof is a little different than the one before it. We are going to use congruent triangles, but it's different because what they're asking us to prove doesn't say anything about triangles, but we're actually going to use some congruent triangles in order to prove this. So let's go ahead and mark our given. So our given is that AB is congruent to AC. And that's all we're given. And we don't even have two triangles. So we're going to have to be a little bit creative here in order to prove that angle B is congruent to angle C. And so what we need to realize is what we're focusing on in this whole unit is using congruent triangles. So that should serve as a hint that we're going to need to split this up into two different triangles. Okay? So what I'm going to do is I'm going to mark where the midpoint of BC would be. Now every segment has a midpoint, so just because it wasn't marked on the original diagram doesn't mean I can't mark it now. So I'm going to go ahead and mark D and say that D is the midpoint of BC. And since D is the midpoint, then those two pieces would have to be the same. BD and DC would have to be congruent. And then that allows us to draw a segment from A to D. And is there anything else we can mark now? Yusuf? Huh? How do we know that? Well, we know that it meets in the middle of segment BC, but we don't know anything about the angles. There's one easy piece of information that is staring right at us that will help us. Okay, Lucas? Okay, now where did we say that there's a right angle? It might look like one, but it doesn't say anywhere that there's a right angle. Max? AD is congruent to itself. It's in both triangles. It's in the triangle on the left and in the triangle on the right, and it's the same for both. Okay, so you guys are looking. Some of you were looking for angles. Some of you were looking for things that looked like they were perpendicular. We have to be really careful about stating things that you think are true, or you might know are true, but we don't have any evidence to support that. Okay, so it may turn out that AD is perpendicular to BC, but so far we don't have any evidence to state that, or it could be done that way, but you have to be able to provide the evidence. So the easier thing to recognize is that whenever we have a shared side like BD, it's in both triangles. So we'll go ahead and use that. And so now do you see why the triangles are congruent? By what method? SSS. And once we establish that the two triangles are congruent, then we'll be able to say that the matching parts, which is B and C, would have to be congruent as well. Okay? So see how we planned the whole thing out before we even started writing the proof? That's typically what you're going to want to do. And so we can make our two-column proof with our statements and our reasons. And so the first statement was the given. AB is congruent to AC. That was given. And then we plotted the midpoint D. So I'll just say let D be the midpoint of segment BC. Okay, and the reason for that, we could just, there's not really a theorem or anything that we can cite there. We can just say every segment has a midpoint. Okay, so every segment has a midpoint. We just labeled it. Okay, and then from that fact, we were able to say that BD was congruent to DC. What would be the reason for that? Okay, Adam? That's correct. Definition of a midpoint. So we said in the step up above that it was a midpoint, and so the definition of a midpoint tells us that the two pieces have to be the same. All right, and then we also said that AD, segment AD, was congruent to itself. Now, do you remember what that's called when we're using an equal sign or a congruent symbol when we say something is equal or congruent to itself, Amy? That's right, reflexive property. Okay, and now let's look at what we have. We have a pair of matching sides that we're given. We have a pair of matching sides from the midpoint, and we have a pair of matching sides from the reflexive property. So notice that I just circled SSS in the side. So that means now we're ready to say triangle ABD is congruent to triangle, what would the correct order be? ACD, and the reason is SSS. So whenever we say that two triangles are congruent, it's going to be one of those methods, SSS, ASA, or SAS. And now that we've established that the triangles are congruent, we can finish it up and say angle B must be congruent to angle C. And what was the reason again for that? Timothy? No, I already wrote the statement. Since we're saying angle, how do I know that angle B is congruent to angle C? Logan?
Corresponding angles of congruent figures are.
That's right. B and C are corresponding parts. Corresponding parts of congruent figures are congruent. So it doesn't make sense to say that, to say corresponding parts of congruent figures are congruent, if we haven't already proven that we have congruent figures. And we have right here in this step. Step 5, we proved that the triangles were congruent. So that allows us to to talk about the corresponding parts of the congruent figures. So that completes our proof now. And so just to recap, we first went through the steps to prove that the triangles were congruent. Once we established they were congruent, then we could talk about the matching parts or the corresponding parts. And since B is the middle letter and C is the middle letter, those are corresponding parts of the congruent figures. Okay, so we used the congruent triangles to prove something about the angles. Okay, now in this next thing, you may not realize it, but we just actually proved something pretty important. Think about what we started with. We started with a triangle, and all we knew was that two sides were the same. Okay, now I want you to think about what we proved and what statement can you make in general about every isosceles triangle. Okay, write it in pencil in case we need to make some changes to it, but go ahead and discuss that in your groups. What did we just prove is always going to be true about isosceles triangles? Okay, Zoe, what did your group decide? What is true about every isosceles triangle?
We said that the triangle has two congruent sides.
That's absolutely right. If a triangle has two congruent sides, then it also has two congruent angles. And in particular, the angles that are congruent are the ones that are across from the congruent sides. So if this was triangle ABC, then angle A and angle C would be the angles that would have to be congruent. So I'm going to state it this way. I'm going to say if a triangle has two congruent sides, then the angles opposite the congruent sides are also congruent. Okay? And just a side note about isosceles triangles. When you have an isosceles triangle, the two sides that are the same are called legs. So that's a leg. AB is a leg, and then BC would also be a leg. And does anyone know what the third side is called? Yes, that's called the base. Okay, so every isosceles triangle has two congruent legs and a base. These angles at the bottom are called the base angles. So another way to state the isosceles triangle theorem is to say in any isosceles triangle, the base angles are congruent. So you might see some textbooks that write it that way. Okay, it's basically saying the same thing as what we did. But what's important that you recognize is that it's the angles that are across from the congruent legs that are the congruent angles as well. Okay? So that's called the isosceles triangle theorem. All right, so we've got one more proof. I'm going to have you guys try this one out in your groups. So before we start the proof, note this definition. When we say that a polygon is regular, what we mean is that all of its sides and all of its angles are congruent. So if I said I had a regular octagon, that would be an 8-sided figure like this. And so if it's regular, that means all 8 of those sides are the same, and all 8 of those angles are congruent as well. So regular means all the sides are the same and all the angles are the same. Okay, so that term is used in this next proof. So go ahead and this is actually, if you want to do it in your book, it's actually on page 251. It's problem number 8. So you could do it in your notes if you want, or you can do it in your read in your book on page 251. That'll save you the time of writing it down. So go ahead and work on that together. I'm going to pass around the tablet and let each group fill in one line and mark some things on the diagram. So if I pass the tablet to your group, go ahead and write something down and then pass it on to another group.
How do you want it? It's like film with these. So, that's good.